Hello guys, welcome back to Math Zone African Motives. Still working on our mathematics and six. So this is the application of area, the calculation of area, the calculation of the moments, that is the first area, moment, and also the distance from the centroid. So this is August 2023 exam that we are going to focus on and see how we are supposed to attempt this typical question. 5.2, 5.21, we are given. The first part was to calculate the point of intersection of the graphs. Y is equal to 2x squared. So we're given two graphs. In this case, the one of y is equal to 2x squared, and also the one of y is equal to 3 minus x squared. So the first question was to calculate the point of intersection. All right, how do you calculate the point of intersection? The point of intersection here, it's on a condition that these two graphs are equal. There is no way that y is going to be equal to 2. Then here we write y is equal to 3 from the same function. It is the same thing that we are referring to. So meaning to say this function and this function are also the same. They are just the same y that we had before. All right. So if it is the same y that we had before, therefore, we can just equate this part of x. All right. Because it is the same thing. So we are going to have it as an equation in terms of what? In terms of x now, just like what we had in terms of y. So meaning to say, we are simply saying 2x squared, therefore, is equal to what? 3 minus x squared. So there we can be able to solve for x. All right, that's a quadratic, but we can take the minus x squared this side. So it's going to be 3x squared is equal to 3. Just divide by 3 by 3. So x squared will be equal to 1. Introduce the square root. So x is going to be plus or minus 1. Remember the square root of a 1. That will be a 1, but we have plus or minus for that square root. All right. Then to get the y value at this point, it is the same thing. At this point, this is the same. We are having same because it's the point of intersection. So you're going to take any one of these graphs. So I'm just going to take one. So in this case, if x is equal to 1, I substitute on this one. So it's 2 times 1 squared, which is a 2. So the value of y there is 2. And when x is equal to minus 1, I substitute again here. So it's going to be 2 times minus 1 squared, of which minus 1 squared is 1 times 2, which is 2. So this is going to give us what? Minus 1, 2. And also there we've got 1, 2. So that is where our graph is going to intersect. Our graphs are going to intersect. They are going to intersect at these 2 points. Okay. Then the other part now, they want us to make, after that, make a neat sketch of the 2 curves, all right, and show the representative strip that you use to calculate the area bounded by the 2 curves. All right, so they were asked to draw the graphs or to sketch these graphs. Y is equal to x squared, and the graph of y is equal to 3 minus 2x squared. Remember, from the quadratic function, if we are given the graph of y is equal to 2x squared, it's just how wide this graph is. So our graph of y is equal to x squared. If it is like this, then the graph of y is equal to 2x squared is going to be inner part like that. It's just how wide it is, but this graph is going to pass through the origin at 0. So this one is just take the same shape of the graph of y is equal to what? Y is equal to x squared. Passes at 0, then it goes up. Remember, this is a graph that is symmetrical to the what? Y-axis. In this case, the y-axis is symmetrical to this graph, all right? So that's y is equal to 2x squared, all right, at point 0 in this case. Then for 3 minus x squared, we know it has a negative there, so you're supposed to have a graph of this nature, all right? At a point where x is equal to 0, y is equal to 3, at a point where x is equal to 0, y is equal to 3, then we can also ask ourselves, what about at a point where y is equal to 0? What are the values of x? We're going to have x squared on this side is equal to 3. Then we'll be having square root of 3, which is plus or minus square root of 3. So the x-intercept will be maybe at square root of 3 somewhere there, something like that. All right. This does not matter about the x-intercept. What matters is just our shape here. So it's going to be like this. All right, guys. Very sorry for this shape, but just something like this. All right. So this here Just gonna indicate it here. All right, so I'm just gonna indicate it here like this. All right, so this gonna intersect at this point. These are the x-intercepts. All right, but our graph is going to intersect. Our graphs, they are intersecting at this point and also at this point. All right, so this is the graph of y is equal to 3 minus x squared. So this is 3 minus x squared, like that. Okay, then the point of intersection at this point where we saw that x there can be -1 versus 2 and 1 versus 2. So the x value here is going to be at what? At 1, and this one it's at -1. So the area bounded by the graph definitely is this one in between. To be bounded is the one that is in between the graphs. So the area that you're going to take is in between the graphs like this. This is where you get your area that way. So as you can see, we have got the limits in x, the x values. We can take the x values as our limits. So meaning to say we can have our strip in the x. There we are not given. We are choosing our own strip. So the representative strip in this case, it's best suit to be of what? Of the y, that the one for the x in this case, since we've got the limits that are directly given for what? For the x. And also, as we know that for area, the strip that you use here is the same strip that you use, is the same concept of area. If the strip is for x, the area is for x. So it can be easier that way. Okay, so that is what we had. We've got everything. Then in this case, 5.22, they want us to calculate the area that was described in 5.21. In 5.21, this is what we are. This is where our graphs are. So what is going to be the area in this case described in this question? The area is bound between two given functions. So we know that there we're going to use our formula, which we also have from our formula sheet. All right, this is 5.22. So the area we said is with respect to x. So the area with respect to x from your formula sheet is given as y1 minus y2 on a consideration that we are given two functions like that. All right, so that's y1 minus y2 with respect to x, whereby we're given the limits a and b. So y1 is the graph that is on top. Y2 is the bottom one. So y1 is this one on top above. This one is the one that is on top on our area. You can see that it's above. Then y2 is this one that is below. So meaning to say this is going to be y1, this one that is above on top. So that's your y1. Y2, this one that is below here, this one, it is below that graph. So that's the idea. So meaning to say we can calculate our area. Everything is there. There's no need for you to make anything the subject here. You're just substituting, integrate the limits from -1 up to 2. In this case, then y1, this is our y1, which is 3 minus x squared. So we've got 3 minus x squared like this, minus y2 being what? Being 2x squared. So this is what we have with respect to x. We're done. So we can just simplify these two, then we integrate. So thus we have got the limits. We said -1 up to +1, not +2, but +1 here. This is +1. All right, so that's a +1 there. So like I said, you can simplify before integrating. That will be 3 here, minus x squared minus 2x squared. These are like terms, so it's -1 minus 2, which is -3. So you're going to have minus 3x squared with respect to x. So at that stage, we can integrate the integral with respect to x on 3x. We're going to integrate with respect to x. So this will be 3x. Then if we integrate 3x squared, it was supposed to be like this. 3x, we add 1 on the exponent. So it was supposed to be 3x to the exponent of 3 over 3 like this. So definitely this and this will cancel. We remain with x to the exponent of 3. So this will be x to the exponent of 3 with our limits 1 and -1 as we are given. So there we are simply substituting what we have at the upper limit minus the lower limit. All right, so what are we going to have in this case? In place of x, we're going to substitute 1, which is our upper limit here. So this is going to be equal to 3 into 1. So that's 3 times 1, which is 3, minus 1 cubed, that's a 1, minus, we substitute 3 times -1, that's -3, minus -1 cubed, it's a -1. So it will be a -1, which is simply a plus. All right, so that is, you can just combine everything straightforward on your calculator. You can combine this, you combine the other one, but if you combine separately, this was going to give you a 2 minus, this was going to give us a -2, and at the end, we get a 4. And this is area, so it's 4 square units, area measured in what? In square units. So that was our area with respect to x. So like I say, the strip that you have, the representative strip determines your area. If it was for y, you use area for y. So this was for x, then you're going to use the area for x. All right, let's move on to the other part. Now they're saying, consider this, calculate the distance of the centroid to the x-axis. All right, to the x-axis, what are we calculating there? We are calculating y, that is the value of y. To the x-axis, or from the x-axis, we are calculating y bar. So in order for us to have that y coordinate or the y coordinate, we are supposed to have the area moment. There's no way we can calculate this without the area moment. So there, the question, they are not asking you to calculate the area moment, but there is no way you can calculate that without area moment, because you know that the y value is equal to the area moment of x over the area. And this we have to be, it has to be calculated, all right? That's the idea there. So from your formula sheet, you are given this formula for the area moment. I explained this and I said that's the RDA. And this, you are supposed to know that it is the same as the formula for the area moment for the y. What differs is what you're going to do on this R and the expression for the area. So this R here, as we are talking about the area moment from the x, meaning to say this R here is the distance. It's the distance from the x. It is representing what? The distance from the x, which is our y bar in this case. That is area times the, just like this, all right? That is the y value at the coordinate, at the center. So what is the y value? We know that we are supposed to have our centroid in the form of xy. So when you are given a function of this nature, when you are given two curves, in this case of this nature with the representative strip with respect to x, I told you guys that you are going to have in this manner your centroid given as x, then we're going to have y1 plus y2 over 2 like this. All right, if it was given in this manner, I said you add your x1 plus x2 over 2 as to what? As to y. That would be the centroid which is the one that you are using as for the y value, the distance. So we said this one, the R here, is the distance from where? From the x-axis, meaning to say it represents what? It represents our y bar. So if it represents that, it means what is representing y at the point of our centroid is what? It's y1 plus y2 over 2. This is the condition that will differ for every question. This is the condition that differs. So like I illustrated in the previous one, I said in another question, if it was like this, whereby the strip is for y, we're going to have x1 plus x2 over 2 as to y. It will change this, all right? Just like moments, the condition of the moments is the same throughout science. In our science there, we talked about moments is the same consideration that you're talking about. It is calculated at a condition. So at this condition, where R represents the distance in the y, and that distance in the y according to our centroid point, which is x as to y1 plus y2, we're going to take this expression. So meaning to say, we can now calculate our area moment. Our area moment with respect to x is going to be the integral of, in place of R now, we are substituting what R is representing the distance, which is y1 plus y2 over 2 times dA, which is the area expression. So this is the area expression that we had before, and we take it from the question. Again, it differs with your question. This one, you take it from your area. According to our area expression, this is our area expression before the integral. You're going to have y1 minus y2 dx. That is what your dA represents. So you take from the area what? From the area expression. From our area expression, we have got y1 minus y2 with respect to x. So that is going to be the formula. So this one is the one that you formulate by yourself. The exam, they give you this only. The format that you're supposed to have, that is what you just need. They just give you a format. Okay, you're supposed to have this format. Okay, it's fine. From there now, what does the format mean? What am I doing on the format? That is the most important part. All right. So factor out the half here, which is on this part. Okay, the limits for that, let us just substitute our limits with respect to x. That's -1 to -1 to 1. Then we can factor out our half here, which is on y1 plus y2 over 2. So meaning to say there, we are going to remain with y1 plus y2 into y1 minus y2, which is a difference of 2 squares. So that's y1 squared minus y2 squared with respect to x, where y here is a function with respect to x. We calculated these functions before. If you take a closer look here, we had y1. In fact, we did not calculate, we're just having from our function this one. It was just direct, all right? Y1 and y2, we have these ones before as they are. Sometimes you have to calculate, maybe it's given in terms of x, then you make y the subject. But in this case, we have these values as they are. So we're just going to substitute y1. So that is this y1, 3 minus x squared like this. Then we're going to square this minus y2 squared, which is 2x squared. Then we're going to square this like this. That is what our formula is saying. With respect to what? With respect to x. That is what we have. So we are supposed to square this, and we square this, then we can collect like terms or whatever that we have. So if you expand your brackets properly, guys, we talked about this previously. So this is -1 to 1, -1 to 1. All right, now we are integrating here. Let us integrate. I talked about, all right, before that, we're gonna expand before integrating. All right, like this. So this here, if you expand your brackets, you're gonna have remember from that identity of a minus b squared, which gives us a squared minus 2ab plus b squared, or you expand your brackets properly, all right, you are going to get 9 minus 6x squared plus x to the exponent of 4. Okay, I explained this one, guys, as much as I don't know how many times. All right, minus here 2 to the exponent is going to be 4x to the exponent of 4. 2 and 2 multiplies is going to be a 4 with respect to x. And also you can collect your like terms inside before integrating. So that will be, all right, I'm always forgetting the limits here. All right, so this will be the integral of, collect the limits, that will be 9. We've got, collect the like terms here. So we've got minus 6x to the exponent of 2, x to the exponent of 4, minus 4x to the exponent of 4. That's 1 minus 4, which is minus 3, x to the exponent of 4 with respect to x. Now we can perform our integration in this case. All right, so let us integrate everything with respect to x. So 9 with respect to x is going to give us 9x, all right? 6 here, it was supposed to be, we add a 1, so it was supposed to be 6x to the exponent of 3. Remember, you divide by the new exponent that you have in this case, which is what? Which is 3. So if you divide by 3, that was going to give us a 2. So that was going to be negative 2x to the exponent of 3. The same thing here, we add 1 on our exponent, so that will be minus 3x to the exponent of 5 over a 5. With our limits, that's 1 and -1 like that. So that is the idea of this question. So we can be able to calculate our area moment in this case with respect to x, about the x, which is going to be half of. You can substitute your limits, the upper limit minus the lower limit, which is when x is equal to 1. This is just going to remain as 9 minus a 1 here. This is b2. A 1 here, that will be minus 3 over 5. So this one you can even just substitute by side by just looking into the question. All right, minus, you do the same thing when x is -1. You're going to substitute -1 here. That will be -9, something like that. All right, let's do this. So this will be a -9 in this case. Here we're going to get a -1 times this, which is a +2, a -1, and this, which is going to be a +3 over 5 instead. All right, so instead you can just simplify it this way. Then from there, what you do is that you have to simplify everything at once, or you can simplify stage by stage. It's up to you. All right, so if you simplify this whole bracket that we are seeing here, we were going to obtain something like 64 over 5, everything there, which is going to give us 32 over 5. This is area moment measured in what? Cubic units, or you can write it as a decimal. There's something like 6,4. So you're going to have 6,4 cubic units. So that is our area moment. But the question was not for us to calculate the area moment. The area moment is something else that we are calculating. The question was specifically mentioned for us to calculate this, which is what? The distance from the x-axis, the distance taken from the x-axis, which is the y, and we said is the area moment for about x over what? Over the area that we are. So meaning to say we are simply taking the area moment for x. So this one is simply a continuation that you are going to make. So therefore, in this case, our y bar from our formula, which you said area moment about x over area, just going to substitute our area moment here, it is 32 over 5 or 6,4, everything. So these are cubic units over the area. We calculated the area before. So if we take a closer look, you see that we calculated our area here. That was our area, which is what? Which is 4 square units. Our area, 4 square units. So there, we are simply going to divide by what? By 4. That is the idea, by 4 square units. So this gives us the distance from the x-axis, which is the centroid distance from the x-axis. That is going to be 8 over 5. So it will be 8 over 5 or 1,6 or 1,6 units. So that is the idea there, just like that. So you see, the moment there, when you're dealing with moments, what is important is for you to know the idea of what, especially on this distance, the distance concept, because that is the moment, that those are the moments now. The R here, the finding how you determine your R here, those are your moments, all right? So we just have to know each and every type. And I think I've explained each and every one of these. So you just have to try and do questions using all those centroids that I explained. So just try by all means to revise as much as you can. More questions to come till we meet again.